GATE 2015 Set 1 Electrical question number 36. A parallel plate capacitor is partially filled with glass of dielectric 4 and the dielectric constant for air is always 1. So it is given the dielectric strengths of air and glass are 30 kV per centimeter and glass is 300 kV per centimeter. Maximum voltage in kV which can be applied across capacitor without any breakdown. Now you see 30 kV per centimeter and 300 kV per centimeter, which one do you think has a lesser dielectric strength? Obviously the air has a lesser dielectric strength because it breaks down at only 30 kV if the separation is 1 centimeter between the electrodes. That is between 1 centimeter if it is 30 kV, it is breaking down. Whereas glass is breaking down at a much higher voltage of 300 kV for the same separation of 1 centimeter. So 30 kV per centimeter will be breaking down faster and analysis will be done at par with the weakest dielectric material, that is air. So let's come to the useful information that we'll be needing in order to solve this question. Now see, capacitance is A epsilon by D, which is nothing but area of the plates into epsilon naught epsilon r. Epsilon naught is the relative permittivity of free space divided by the separation between the plates. So this is A, this is D, and the material that is of epsilon permittivity, which is epsilon naught epsilon r. Now it is given that C of air equal to A epsilon naught by D. Now C of glass equal to A epsilon naught epsilon r by D, where epsilon naught is given as 4. So C air times 4 is C glass. Now also you need to remember one fact, that is D for both is same, as well as area is also same. Coming to the solution, this layer has air and this layer is filled with glass. Both are 5 millimeters separation as is given in the question. Both 5 millimeters separation, and this epsilon r relative permittivity is 4 and this is 1. Now if air is breaking down, that is breakdown voltage is reached, that is delta V for air capacitor means 30 kV per 10 millimeter. So per millimeter it will be 30 by 10 into 5 kV for 5 millimeter. So the breakdown will occur at 30 into 0.5 kV, which is nothing but 15 kV. Now same, if glass is breaking down, delta V glass during air breakdown, because even if air is breaking down, the glass is not breaking, but still we have to consider that case only, because it is asking in the question that maximum voltage that can be applied without any breakdown. So we need to consider this case only, where the air is only breaking. So that will be the maximum voltage, because we don't want any of the dielectrics to break. So at the moment air was breaking, that is during this 5 millimeter, when 15 kV was applied across these points during the air capacitor. So at that moment, what was the delta V for the glass capacitor? That is found out to be, now we know E glass is 4 times epsilon air, that is relative permittivity of glass is 4 times relative permittivity of air. So we can comment that capacitance of glass is 4 times capacitance of air. Now we know Q equal to CV. Now since these are connected in series, the air capacitor, air and glass capacitors are in series. So by Gauss law, Q same. Now C proportional to 1 by V. Now if C glass equal to 4 times C air, it implies V glass, okay, equal to 1 by 4 times V air, which implies that V glass means delta V glass, that is voltage across the glass capacitor, and delta V air means the voltage across the air capacitor. So already air capacitor voltage difference is 15 kV. So at that instant the voltage across the glass capacitor is 15 by 4 kV. Now why we are doing this? Because we actually want to find the potential that can be maximum potential that can be applied across this capacitor plates. These are the plates and these are the dielectric slabs that are inserted. So air is breaking. At that moment we found out what is the voltage of the glass. Then V net equal to, we should add these two. Adding these two, we get the net voltage that should be applied, and that can be applied maximum, and then from that point capacitor dielectric breakdown starts to happen. So 15 kV for air capacitor, and glass capacitor at that point was 15 by 4 kV, so 18.75 kV. So 18.75 kV is the